As a conclusion, Planck discovered or proposed that when we heat a metallic piece, yani when we give energy to the metallic piece, the energy absorbed as heat is equal to the energy emitted as light, and the energy of light is directly proportional to the frequency of the light emitted. So E absorbed equal E emitted equal N, which is integer number, times H اللي هي Planck constant, times mu, which is the frequency of the light emitted. Einstein proposed that the electromagnetic radiation is itself quantized. So this electromagnetic radiation has energy of known value. So the energy is quantized. That means it could not take any value. Einstein described the electromagnetic radiation as a flow of particles we called photon. Planck talked about electromagnetic radiation as a wave characterized by frequency mu. Einstein talked about electromagnetic radiations as a flow of particles called photons. And the energy of the photon is equal h nu, which is equal hc over lambda. So now we say that the concept of the particle is directly close to the concept of the wave. And we will prove that light can be described in the particle model as a flow of photons or as a flow of particles, and at the same time it can be described as a wave characterized by lambda and mu. And the energy of photon is equal to N to H nu equal Hc over lambda. So E equal is the energy of the photon, H is a Planck constant, mu is the frequency of the radiation, and lambda is the wavelengths. I know that you did not get the real difference between Einstein and Planck. As summary, Planck described that the energy absorbed, whatever is its form, is equal to the energy released as radiation, and the energy of radiation is equal NH nu. Einstein described the radiation as a flow of photons, and each photon has energy which is equal to H nu. And how many photons? If we have n photons, so the total energy is equal NH nu. This is close to the concept of Planck that discovered that E equal NH nu, but Planck described n as integer number and he did not know the real meaning of n, but Einstein described radiation as flow of photons and he obtained the same relation, E equal NH nu, and n is the number of photons particles in this radiation. So the two concepts are close. Example, calculate the number of photons in a radiation that has lambda 337 nanometer and total energy 3.83 megajoule. According to Planck, I can read this radiation as a wave of lambda equal 337 nanometer. But according to Einstein, this wave or this radiation is composed of particles which are the photons. So what is the number of photons? I take the two models. The model of Planck, E equal NH nu. So Planck talk about wave. And the model of Einstein, E is the radiation is a flow of particles or a flow of photons, where E equal the number of photons times H times nu. So E Planck equal E Einstein. It's impossible to have the same type of radiation with two different values of energy. So I apply the relation E Planck equal E Einstein. So E equal NH nu. E I calculated from, we have the lambda and we have the energy. So E equal Hc over lambda, and E total equal E of the photon times the number of photons. So E total equals 3.37 10 to the power 2, and E of the photon is equal Hc over lambda. H is known, C is known, lambda is known, so I calculate the E of the photon. Or I can apply directly the relation without saying E Einstein equal E Planck. I can apply a general relation, E equal NH nu. E is given 3.83 megajoule. N is the value to be calculated. H is given, and mu is calculated from the wavelengths lambda. So I can calculate N, which is the number of photons, 6.49 times 10 to the power 15 photons. What is the meaning of this value? The meaning of this value, if I have a radiation with total energy 3.83 megajoule, and the lambda of this radiation equal 337 nanometer, I can suppose that this energy contained is a flow of particles, and the number of particles is equal 6.49 times 10 to the power 15 photons. What is the frequency of radiation required to supply 1 times 10 to the power 2 joule of energy from 8.5 10 to the power 27 photon? So I have the number of photon N, which is equal 8.5 10 to the power 27. And I have the energy, which is equal 1 times 10 to the power 2 joule. So I apply the relation E equal NH nu. E is known, N is known, H is known, so I calculate the frequency of the radiation, which is equal in this application 1.8 times 10 to the power 7 second minus 1.